Hi everyone, welcome to your YouTube channel, that is Civil Engineering Choice. We have started the series of shear force and bending moment diagram. Means we have uploaded few videos on the shear force and bending moment diagram, and this is the new video for the next case. Okay, so these are the contents that we are covering in the shear force and bending moment diagram, and these are the topics that we have covered in the last few videos, like the definition of beam, types of supports and corresponding reactions, sign conventions for all the horizontal, vertical, shear force and the bending moment diagram. Then we have covered the definition of shear force and bending moment diagram. Then we have cover the differential equations of equilibrium for beam elements to see the bending moment and the shear force variation with the loading. Then we have covered the general steps that are required for the shear force and bending moment diagram calculation. Then two simple cases that we have covered, that is simply supported beam carrying centrally point load and simply supported beam carrying eccentric point load. And today we are going to focus on the simply supported beam carrying a uniformly distributed load. Okay, so for the uniformly distributed load, first we are going to consider the simply supported beam like A and B. Those points having simple support at A and B point and carrying UDL on entire span. UDL means uniformly distributed load on entire span. So the first thing is noted when we are calculating the support reactions for such type of loading. So first we have to convert that UDL, means uniformly varying load, in a point load, and then we can apply the equilibrium conditions to calculate the support reaction. Okay, so how we can convert this load in the means uniform load in the point load? So just we have to multiply with the load intensity with the total span that covered by the load. Now here we can see the load intensity is W that we have considered, and the span or that particular UDL is spread on the span of L. So the point load of this UDL is W into L, and whatever point load we have considered over here, that is WL, that will act at the center of that particular span. It means it is L by 2, L by 2. Similarly, we will take one example. Let's say suppose we have one beam, okay, again simply supported beam, and that simply supported beam carrying UDL at 4 meter, okay, UDL at 4 meter, and the total span of that UDL is, let's say, 8 meter. Okay, and now we want to convert that UDL in the point load, and let's say intensity of that point load is 10. Intensity is 10 kilonewton per meter, 10 kilonewton per meter. So how we can convert that UDL to the point load? So as we discussed, first we have to multiply load into span. So here load is 10 into span, or that UDL spread is 4 meter. So point load is 10 into 4. The point load is 10 into 4, that is 40 kilonewton. Okay, 40 kilonewton, and that load will act in the center on where that UDL is covered. So now the total span is 4 meter, correct? So the distance of that point load from one of the end is 2, that is 4 divided by 2 is 2. It means that point load will act at the center. So this is a simple funda to convert UDL into the point load. So let's start with our numerical. So as we know, for the calculation of shear force and bending moment, first we have to calculate the support reaction, and for that support reactions we have the equilibrium conditions, three equilibrium conditions, that is summation fx, summation fy, and summation m equals to 0. Out of that, first we are applying the first equilibrium condition, that is summation ma equals to 0, where summation ma equals to 0 means what? The moment, algebraic sum of moment at a point is equals to 0. So when we are taking the moment at a point of all loading, so here we can see two loads are there. The first is W, that is UDL, and the second is the reaction at B point, that is, let's say, RB. Okay, RB. So the moment of that UDL is, we can calculate by converting that UDL into the point load. And just remember that whatever we are converting that UDL into the point load, it is an imaginary point load, but if we see the actual behavior of your beam under the UDL and for the point load is a different. Just for calculations we are converting that UDL to the point load. So how we can convert? Just we have discussed. Just consider the imaginary point load, okay, and the point load is load into span, where load is W and the span is L. So the point load is WL. Okay, so point load is WL, and that WL point load will act at center. The total span is L, so center is at L by 2. So the distance of that imaginary point load is L by 2 from A point and L by 2 from B point. Okay, that is a simple thing. Now we have to take the moment of that WL point load and RB point load at the A point. Okay, so for equilibrium conditions, we can use any sign convention: clockwise positive, anti-clockwise negative. But generally, our practice is clockwise moment positive. So if we take the moment of this WL, okay, so that UDL is acting moment clockwise. Okay, so that moment is WL into L by 2. Okay, WL into L by 2 positive, and the moment of RB is anti-clockwise, so it's minus RB into perpendicular distance is L from A point. So this is the moment at A point for this entire diagram. Let's we'll see it. Okay, WL into L by 2. Okay, WL into L by 2 minus RB into L, minus RB into L. Now take here we have to calculate the RB. Now take that whole term in on right side. So it will RB into L is equals to WL into L by 2. So here LL get cancelled. The remaining term is WL by 2. So RB is equals to WL by 2. So we got support reaction at B point. So support reaction at B point is WL by 2. Now applying another equilibrium condition, that is summation Fy equals to 0, we can easily calculate another support reaction at A point, that is Ra. So summation Fy means what? So algebraic sum of all vertical forces. So here we have considered one support reaction at A point, that is Ra. Okay, and at B point RB. Okay, Ra and RB, where Ra is upward and RB is also upward, so both are positive. So it is Ra, this will be Ra plus RB, okay, minus this force is in downward, so minus W into L is equals to 0. That will be the summation Fy equation for the simply supported beam carrying UDL on entire span. So here we can see Ra plus RB minus WL. RB already we have calculated, where RB is WL by 2, just put that value. So Ra plus WL by 2 minus L by 2. So WL by 2 minus L by 2 is a L by 2. Here we can see it is WL by 2. How that L by 2 will come? The equation is WL by 2 minus WL. Okay, just take WL common. The remaining term is 1 by 2 minus 1, where 1 by 2 minus 1 is minus 1 by 2 into this W, so it is WL. So the equation here is Ra E minus WL by 2 is equals to 0. Now take this equation on right side, so we will get Ra is equals to WL by 2. So now here we have got the reaction at A and B point, that is Ra and RB, where Ra is WL by 2 and RB is also WL by 2. Now next step is calculate the shear forces at each point, and here we can see only 2 points are there, that is A point and B point. Okay, it means we have to calculate the shear force only at A and B point by taking left and right section. So if we take first A point, then shear force A left, just focus on left of that particular section. There is no any reaction or the loads on the left of that section. That's why the shear force at A left is 0. Okay, shear force at A left is 0. Now after that, take a section on right. Okay, after that take a section on right of that A point and then focus on left. And if you see on the left side, one force is there or one reaction is, that is Ra, and the direction of that Ra is upward, so we have to take it as a positive. Okay, so the shear force A right is Ra and Ra is WL by 2. After that, directly we can take the shear force B left. Okay, and if you focus on left of that particular section, there are two forces, that is Ra and UDL. So Ra is upward, so we can take it positive, okay, but W is in downward, means UDL is in downward, but already we have converted that W in the point load, that is WL, okay. WL is equals to, we can directly take as a 0, okay. So we will see shear force B left, it should be left, okay. B left RA minus WL, where RA is WL by 2 minus WL. So WL by 2 minus WL is minus WL by 2. Already we have discussed how that equation we have solved in the support reaction. So likewise we can solve here also. Just take the WL by 2 as a common, remaining term is 1 by 2 minus 1. So 1 by 2 minus 1 is a minus 1, okay. Already we have discussed it. So just divide the videos and look how we have calculated. Now B left means B right. Sign convention is wrong. Here left and here should be right. Okay. So on B right means if we take the section on B right, then on left there are three forces, RA, RB and one reaction. Okay. RA, RB reactions and one UDL. So RA upward positive, WL downward negative, and RB upward again positive. Where RA and RB, where RA is WL by 2, RB is WL by 2, and the remaining term WL by 2 is as it is. So WL by 2 plus WL by 2 is a WL, where WL minus WL is 0. Okay, so that equation will come as a 0. Okay, once we calculate the shear forces at each point, then we can draw the shear force diagram. Okay, just for the shear force diagram, draw the reference point at A and B point. Okay, then take a base line. Okay, then A left is 0, but A right is WL by 2, so it's WL by 2 at A right. Then from A to C point or any intermediate point, the bending moment diagram is straight. Okay, and B left, it is minus WL by 2. Let's see, it is minus WL by 2. Minus means it is below the baseline, and at B right it is goes to the 0. So this is the shear force diagram for simply supported beam carrying UDL on entire span. So once you calculate the shear force diagram, the next step is calculate the bending moment. Okay, bending moment diagram. So for that bending moment diagram, first we have to consider the points and then take the moments at each point. Now again, here we have only 2 points, that is A and B point. So we need to take the moment only at A and B point. Okay, but before that we have to decide the sign conventions to calculate the bending moment at the each point. Okay, and already we have discussed the sign convention. The sagging sign convention is what? If you take the section between these, if the moment, clockwise movement on the left of that particular section, so that movement we are going to consider as a positive. Sign convention already we will discuss in the last few videos. Okay, so directly we will take the moment at A point. So if you take the moment at A point, that is MA, okay, and if we focus on the left of that particular section, we are taking moment at A point, means we are considering the section at A point. Okay, just take the section at A point and consider the left part of that particular diagram. There will be no any force. It means the bending moment at A point is 0. Okay, now the next point is B point. It means directly take the section at B point. Okay, and then focus on left. And if you focus on the left, there are two forces again, RA and W, UDL. So we have to take the moment of that RA and W, where RA into perpendicular distance is L. As per the sign convention, this is positive. Okay, and the moment of this UDL, okay, already we have converted it, that is WL by 2, converted it in the point load, that is WL, and we'll act it at the center, that is L by 2. So moment of that UDL is WL into L by 2, and due to anti-clockwise it is negative. So the moment at B point is RA into L minus WL into L by 2. Okay, RA already we have calculated, where RA is WL by 2, just put that value WL by 2, okay, into L minus WL into L by 2. So if you solve it, so it will be the WL square by 2, and this will also WL square by 2, where WL square by 2 minus WL square by 2 will be 0. Okay, so the bending moment at B point is also 0. Now see here, the bending moment A as well as bending moment at B is 0. But already we have discussed one point in the concept, That is, when your shear force is 0, at that point your bending moment is maximum. And if you see over here, our bending shear force is 0 at C point, it means our bending moment is maximum at C point. But now here we have the symmetric diagram and symmetric loading. That's why we can say that the maximum bending moment is at center, or the shear force is 0 at the center. But suppose we don't know where the shear force is 0, so in that case we have to use the procedure that we are discussing now. So for every numerical or every type of numerical, we can use that steps to find out the actual position of your zero shear point and the maximum bending moment where your shear force is 0. So we can apply this procedure for any type of numerical. Now we are applying this procedure only for the standard case, but you can use this procedure or use these steps for every types of numerical to find out the position of zero shear point and the maximum bending moment. Okay, so now let's start with the calculation of position of zero shear point. Okay, so how we can consider it? Just take the section between A and B. Okay, why we are taking the section between A and B? Because our shear force is 0 between A and B point. Okay, our shear force is 0 between A and B. That's why we are taking one section XX between that span, A and B span. Okay, and consider that particular segment having distance X. Okay, means whatever section we are considering, that section having distance X from the any one end, either it is A or B. Now we have started our calculation from left to right. That's why I am considering that X distance is from the left point. So here we are assuming distance of that particular section, XX section, from the A point, that is X. Now we have to take the shear force at that particular section. Why we have to take the section? Because we have to calculate the position of zero shear point. Okay, we are calculating the position of zero shear point. That's why we have to take the shear force. When we have to calculate the position of zero bending moment, in that case we have to take the moment of that particular section. Okay, just clear it. For the calculation of shear force position, take shear forces at the section. When we are calculating the bending moment position, zero bending moment position, we have to take the moment at that particular section. That is a simple thing. Okay, so here we are taking the section shear force at that particular section. Okay, now on left part, left of that section, again two forces are there, that is RA and that W. Okay, so the shear force at XX section is equals to 0, and if you take that one, so RA minus WX. Why WX? Now already we have discussed, when we are converting that UDL into the point load, we have to multiply that UDL with the span over that UDL has spread. Now here only the X distance is covered by this W. Okay, that's why we are considering point load is W into X. Okay, the shear force is RA upward and the point load due to that UDL is WX, and the direction of that WX is downward, so it is minus WX. So here already we have calculated the RA, value of RA, where RA is WL by 2, correct? RA is WL by 2. Now WL by 2 minus WX. Now here we have to calculate the X. So just convert that equation in the form of X, where WL by 2 is equals to WX. So WW get cancelled. Remaining term is L by 2. It means our X is equals to L by 2. Okay, where X is equals to L by 2. It means our zero shear point or the shear force is 0 at L by 2 from the A point, because X distance we have considered from the A point. So this distance is L by 2. So by default, another distance is also L by 2. How L by 2? That is L minus L by 2. So the remaining term is L by 2. So our shear force is 0 at L by 2 from the left support. It means our maximum bending moment at the L by 2 from the zero support. Now here we are considering our shear force is 0 at C point. It means at C point there will be the maximum bending moment. Now we have to calculate the position of that maximum bending moment. How we can calculate the maximum bending moment? Just take the section at that C point, okay, and take the movement at that particular section. So movement at C point, okay, by taking left portion, again by taking left portion, let's say this is C point. Okay, movement of RA, it is clockwise, so positive RA into WL by 2, and the movement of that W. Now this distance we know, it is L by 2. So the point load is W into L by 2, that is UDL to point load, and that point load will act at center of that span, means WL by 2 whole divided by 2. So it will be WL by 4. Okay, it will be WL by 4. So W into L by 2, it is UDL to point load, where L by 4 is the distance or the movement of WL by 2 point load. So just solve this, where RA is WL by 2. Already we have calculated. RA is WL by 2 into L by 2 minus W into L by 2 into L by 4, where this equation is WL by 2 into L by 2 is WL square by 4, and this equation, if you solve this equation, so it will be WL square by 8. So WL square by 4 minus WL square by 8 will be the WL square by 8. How? Just consider WL square by 4 as a common remaining term. WL square by 4 we have taken as a common, so 1 minus 1 by 2, correct? 1 minus 1 by 2. So just take cross multiplication. ये bracket कैसा होगा? 1 into 2, that is 2, minus 1 whole divided by 2. So 2 minus 1 is 1 divided by 2. Okay, bracket क्या होगा फिर? 1 by 2. So WL square by 4 into 1 by 2, that is WL square by 8. So the bending moment at C point is WL square by 8. It means the maximum bending moment of simply supported beam carrying UDL on entire span is WL square by 8. So just remember these two formulae. First, simply supported beam carrying UDL on entire span. Support reactions, A support reaction is WL by 2, B support reaction is WL by 2, and the maximum bending moment is WL square by 8. Remember this formula as a standard case, so it will help you to calculate the direct maximum bending moment and shear force for third standard case, that is simply supported beam carrying UDL on entire span. Okay, so thank you very much for watching this video. As we discussed, we are uploading some videos related to shear force, bending moment diagram, strength of material. Then we will upload some videos on the reinforced cement concrete, means RCC steel pre-stress. Okay, so I request everyone, please like and subscribe my channel, so I will get motivated and you will get that videos notifications. And also, if you have any doubt or you want any type of another video, so please type the topics on which you want the videos. Okay, so thank you so much.